lines, we're going to focus on the slope, we're going to focus on parallel lines, and we are going to focus on also perpendicular lines. So which are slopes that are negative reciprocals, or the product of the slope is -1. So for example, the slope here is 3. So if I were to find a perpendicular slope, what would the negative reciprocal of 3 be? So what would the negative reciprocal of 3 be? Remember, the reciprocal is just taking the whole number and flipping it into a fraction. Negative just implies adding a negative. Thank you, Kushbu. -1/3. If I say your name wrong, just correct me. Okay, so that would be the negative reciprocal. So a tangent line is a line that touches a curve at only one point in the nearby region. So for example, if I want to focus on this point over here, my tangent line is only going to touch the nearby region here. I'm going to slightly touch it, okay? So it's a line that most closely resembles the curve at a particular point. So when we have a curved graph, you can represent it by using multiple tangent lines. The tangent lines are just used to find the rate of change at that specific point. So we read graphs from left to right. So if I were to ask you guys if the slope of this tangent line is positive or negative, what would you say that it is? Positive or negative? Remember, we read graphs from left to right. It would be a positive slope because it is increasing as we go from left to right. And then we have a secant line, which is a line that intersects a curve at 2 points. So we can have a point here and a point over here. And by connecting those lines, we have our secant line. And this involves the general trend of the graph. So again, we read graphs from left to right. So what is the general trend of that secant line? Is it increasing or decreasing as we go from left to right? It is decreasing, okay? So at that point in time, if I was to find the slope of the secant line, it would be a negative slope. So this is our tangent line. It touches a specific point, or touches a point very close to our specific point. And the red line is going to be called our secant line. All right. So these are the two most important things that we are going to learn about when it comes to tangents and the rates of change of a specific curve. Okay, so hopefully everyone's doing well. Like I said, I'm recording this, so you'll get to see this later on or tomorrow morning. So we have a linear function, so we know y equals mx plus b, where the slope is m and the y-intercept is b. We have it in standard form, which is ax plus by plus c is equal to 0. Or we can come up with an equation using our formulas. So we have y minus y1 is equal to m, which is a slope, times x minus x1. Okay, so if we have our slope and our our specific points on the graph, we can come up with a line, okay, with an equation of a line. So this is where example 1 comes into play. So we want to write the equation of a line that's passing through the points 1 and 4 and 5 and 2. Okay, So we have to find our slope first. So we do that by doing y2 minus y1 over x2 minus x1, which means our x1 and y1 is our first points, and our x2 and y2 is our second point. So that means we're going to take 2 minus 4 over 5 minus 1, and that gives us negative 2 over 4, which simplified gives us negative 1 over 2, and that would be our slope. So now what you guys have to do is use this equation over here to come up with the equation of the line. So I'm going to start you guys with the general equation that we have, which is y minus y1 is equal to m, which is our slope, times x minus x1. And I want you guys to come up with an equation for that line that's passing through those 2 points. Remember, y1 and x1 and y1 have to do with the first point in our set of points. Okay, once you have your equation, let me know what it is, and you can leave it in standard form. Because the question is asking the equation in standard form. So would anybody like to share their answer and how they got their answer? Anybody willing and ready to give their answer? All right, nobody wants to give an answer, so that's fine. I can go ahead and do it. So based on our points, we have our y1 and our x1 and our slope. So we're going to take y minus y1, which is 4, which is equal to our slope of negative 1 over 2 times x minus 1. Once we have that, we get y minus 4 is equal to negative 1/2 x plus 1 over 2. To make our lives easier, because we hate fractions, we can multiply both sides by 2. Which means we are left with 2y minus 8 is equal to negative x plus 1. And now we're going to move everything over to the left side so that we can make it in standard form. So we get x plus 2y minus 9 is equal to 0. Did everyone get that answer? Yes, no, maybe. All right, so I got Anna who says yes. Anybody else got that same answer? Hey, Ian, what did you do wrong? Or what do you think you did wrong? Okay. So for this one, to get to standard form, it's easier to go from this equation, and then it gives us the standard form. Okay. So when you get this, you can easily convert it into ax plus by plus c is equal to 0. Yep. Everyone messes up with fractions because we all have a hatred for them. Who here hates working with fractions? So Sad, Leanne, Madge. Oh, damn, you all hate fractions. Jeez. I think fractions is the bane of existence for all of you in math, to be honest. No, Ian, that was not a trick question. Most kids or most students really don't like working with fractions. They prefer working with whole numbers. So in this lesson, we're going to be introduced to limits. So a limit, okay, so when I talk about limits, we said in the beginning, it is the maximum or minimum that something can go to or approach. It's a prediction. So the tangent problem, so find the equation of the tangent to the parabola, y is equal to x squared at the point 2 and 4. We are given the point 2, 4, but we need the slope or another point on the line, okay? We cannot find it because we do not have a second point. So usually this would be easy if we had 2 points, but in this case, we only have 1, which makes it harder for us to come up with a point, or to come up with a tangent line or slope or an equation without the second point. So how do we solve this? We want to sketch the curve, y is equal to x squared, and we want to label the points 2 and 4. We want to choose any point Q on the curve of y is equal to x squared, to the left or to the right of P. Remember, Q is close to P, but it does not equal the point P. Okay, so we want to join P and Q to form a secant line PQ. Okay. So I'll explain what that means as we move along. So as Q moves along the curve towards P, the slope of the secant line becomes a progressively better estimate of the slope of the tangent line at P, therefore moving the point Q closer to the point P, and we calculate the slope. So what that basically means is this. So I'm going to locate 2 and 4, and I'm going to label that P. So this is my point P. Okay, I'm going to put it in the inside because it's easier. Okay, so if we want to draw a secant line, I can literally pick point, this can be my Q, and then my secant line is going to be from P to Q. Okay, let's see, work with me. So this is going to be my secant line. However, why is a secant line not as accurate as a tangent line? Let's see if anyone can give a logical or a good explanation for this. Why is a secant line not as accurate as a tangent line? Does anyone want to take a stab at that answer? Why is a secant line not as accurate as a tangent line? Anna?
Is it because like secant lines intersect in 2 points and tangent lines only intersect at 1 point?
The tangent line intersects closer to that 1 point, okay? So Q is so far away from P that my rate of change for P is not going to be accurate, okay? So what it's basically telling us is if we move Q closer, so let's say here, our tangent line becomes this, which means that my slope is more accurate at this point because P and Q are close together, but P and Q cannot be the same points, okay? So remember, P and Q cannot be the same. So as you can see here, the closer we get to P, the more accurate of a slope we get for the rate of change at the points 2 and 4 of y is equal to x squared. So as we move forward, this is where the concept of limits come into play. So the slope of the tangent to a curve at the point P is the limiting slope of the secant PQ as point Q slides along the curve towards P, which means that the slope of the tangent where x is equal to P is equal to the limit as Q approaches P of the slope PQ. Okay, this may sound a bit confusing, like what kind of language is this, sir? I'm confused. When we apply this, it's basically a complicated way of saying, basically, what is my slope of the curve y is equal to x squared as my point Q approaches my x value of positive 2. Okay, so our P is our point. So this is always our x value. So it's basically asking us, what is my slope reaching as Q approaches a value of 2? Okay, so we are going to get to that in this chart. So I'm going to show it graphically first, and then we can figure out what the limit means. All right, so here is our first example. So I want to find the equation of the tangent line to the parabola y is equal to x squared at the point 2 and 4. Okay, so there's two cases that we have to do. We have to see what the parabola, or the point Q, if we have a point Q, as it approaches our p value from the right. Okay, so 2 and 4, this is our p value. Okay, so our p value is going to be our point of reference. So as Q approaches P from the right, so as Q approaches P from the right side of the graph, which is over here, we need to figure out how the graph is reacting as we come from the right of the graph down to our point P. So we're going to be taking points that come from the right of P. So as you can see, we have 2.5 is getting closer to 2, 2.1 that's getting closer to 2, 2.01 is getting closer to 2, and 2.001 is getting closer to 2. So this is going to tell us what our y values are approaching when we are getting closer to 2. So what we are going to do is we are going to take 2.5 and sub it in for x squared. So when we take 2.5 and sub it in for x squared, we get 6.25. And we're going to find our slope. So again, we have, this is x1, y1. This is x2 and y2. So we're going to find our slope, which is going to be m is equal to 6.25 minus 4 over 2.5 minus 2. So that is going to give us 1.75. Let me get my calculator. I don't want to be wrong. So 6.25 minus 4. Sorry, it's 2.25. Divided by 0.5. Which means my slope is going to be 4.5. And now we're going to do the same thing for 2.1. 2.1, sub it in for the formula, x squared. That's going to give us 4.41. And if we calculate our slope then becomes 4.1. Okay, same thing with 2.01. We got 4.0401. Once we calculate our slope, it becomes 4.01. And last but not least, we sub in 2.001 for x, and we get 4.004001, which means our slope is going to be 4.001. So now, if I write this down, so we're having our limit as q approaches p from the right. The slope of PQ is approaching what? So what is my slope approaching as we get closer and closer to 2 and 4? 4. So my slope is getting closer and closer to 4. Okay. However, we have to do that same thing with Q approaching our point P from the left. Okay. So we're going to do another chart, and it's going to involve the same thing. So I want you guys to see if you guys can do that chart by yourself. So we have to figure out Q approaching P from the left. So basically all our Q values are going to be approaching from the left. Okay, so P is getting closer and closer to positive 2. Okay, so I want you guys to try to fill in this chart. Remember, our equation is y is equal to x squared. And I want to see what you guys notice about the slopes each time. So again, sub 1.5 for x, 1.9 for x, 1.99 for x, and 1.999 for x. Notice how if you keep adding more 9s, Q will never be equal to the x value of P. Okay, when we subbed in 1.5 for x, what was our y value? Okay, 2.25. And Leanne, if you calculated the slope, what was the slope of PQ? Okay, so this one's where it becomes funny, okay? So remember, we read graphs from left to right, okay? So in reality, our x1 and y1 is going to be at our Q points, and our x2 and y2 is going to be on our second point, okay? Because we read graphs from left to right, that is, I know it was a bit confusing, but hopefully some of you caught that. Now that you know that these are going to be x1 and y1, what is my slope of PQ going to be? Just going to give you guys a reminder, we read graphs from left to right. Okay, 1.375. Let's see if anyone else got that answer. That's okay. That's fine. So we have our y2 minus y1. So we have 4 minus 2.25 divided by 2 minus 1.5. So this is going to be our m. So we get 4 minus 2.25, which gives us 1.75 over 0.5, which should give us a slope of 3.5. Did anyone get 3.5? Okay, 3.5. All right. Now, if we sub in 1.9 for x squared, what do we get as our y value for 1.9 when we sub it in for x? Okay, we're going to get 3.61. And hopefully you guys got your slope to be 3.9. Okay. You guys get 3.9 as your slope? All right. And then you're going to get 3.9601. And then your slope, if you guys are going to, you guys can probably assume 3.99. And then the last one, we have 3.996001. And our slope becomes 3.999. So now we write as the limit of Q approaches P from the left side, the tangent of P and Q is equal to what? What is it getting closer to? So what is its limit? 4. So because the limit approaching P from the right and P from the left is 4, we can then say that the slope of our tangent line when x is equal to 2 is going to be positive 4. So at that point, the graph has a slope of positive 4, which means that the rate of change is positive and it's increasing up, okay? So in advanced functions, when we're finding the slope of a specific point on a line, is that known as the average rate of change or the instantaneous rate of change? You guys have a 50-50 shot of getting it right. It is the instantaneous rate of change. So the slope of the tangent is the instantaneous rate of change. Now that we have the slope of the tangent line, we can come up with our equation. So we can use y minus y1 is equal to m times x minus x1. So let's see, I'm going to give you guys a couple of minutes to figure out what my equation of the tangent line is going to be at p is equal to 2 and 4. And once you have your answer, you can type it in the chat. Okay, that's fine. Or you can move everything else to the right. So you can keep everything positive and only the y is negative. So thank you. So we're going to get y minus 2 is equal to 4 times x minus, x minus 2. So we get y minus 4 is equal to 4x minus 8. So let's just keep the x positive. So we're going to leave it on the right side. So you get 0 is equal to 4x minus y minus 4, which is the same thing as negative 4 plus y plus 4. So the point you should use when finding the equation of the tangent line is the point that we were given at the beginning. So 2 and 4. Okay, when you're finding the equation of the tangent line, you're always using the points that we were given at the beginning. So that is basically it. I'm going to stop the recording for this lesson right here. But there's, I think, one more example. So we're going to go over that. So this is just going to appear on YouTube.